Good morning, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. Today my topic is Histogram Processing. So what is Histogram Processing? Histogram Equalization is a computer image processing technique used to improve contrast in images. It accomplishes this by effectively spreading out the most frequent intensity values, that is, stretching out the intensity range of the image. So in any image processing context, the histogram of an image normally refers to a histogram of the pixel intensity values. This histogram is a graph showing the number of pixels in an image at each different intensity values found in the image. So, suppose we are taking one image. I am taking the image size is a 4x4. So each pixel I am giving some intensity values 0, 255, 126, 98, 56, 0, 255, 90, 10, like this. So each pixel have the intensity values are there. So when Histogram equalization is a computer image processing technique used to improve the contrast in an image. So it accomplishes by the effectively spreading out the most frequent intensity values, that is, stretching out the intensity ranges of the image. So suppose these intensity values are there. Suppose it is a 0, means low intensity, 255 high intensity values. So I want to improve the increasing these intensity values. These values are, I have to decrease the intensity values. Why? Because I need more contrast. So when we are going for the accomplishes this effectively spreading out the frequent intensity values, so it is used to contrast an image. So I have to increasing the contrast or decreasing the contrast. So histogram is a technique, or it is an equalizer to adjusting or to improve the contrast of an image. So it is a process to improve the contrast or frequency intensity values. We have to adjust the intensity values. And the image processing context, the histogram of an image normally refers to a histogram of the pixel intensity values. This histogram is a graph showing the number of pixels in an image at each different intensity values found in that image. So the image enhancement can be done by histogram equalization. So every image enhancement, suppose I want to improve the contrast I have to improve or I have to decrease. So shall we call, is it enhancement? Yes, it is the enhancement technique. Image enhancement can be done by histogram equalization. Okay, so here I am doing some image enhancement. What is the enhancement technique? I have to improve the contrast levels. Okay, so this histogram equalization is a technique for adjusting image intensities to enhance the contrast. So I have to adjust. So 0, I have to improve the some 0 to 100. So 255, I have to adjust to the some 120. So is it possible to change? Yes, it is possible to change the intensity values. So this equalization technique to adjusting the image intensities to enhance the contrast, and this method usually increase the global contrast of many images, especially when the usable data of an image is represented by close contrast values. Histogram modeling technique, or example, histogram equalization, provides a sophisticated method for modifying the dynamic range and contrast of an image by alternating that image such that its intensity histogram has to be desired shape. So histogram enhancement, image enhancement is done by histogram equalization. So what is the histogram process means? Improve the adjusting the contrast levels. So histogram equalization is a technique for adjusting image intensities. So that is a enhancement of the image or enhancement of the contrast. So this method increasing the global contrast of many images, especially when the usable data of the images is represented by close contrast values. Histogram modeling technique, example, histogram equalization, provide a sophisticated method for modifying the dynamic range and contrast of an image by alternating that image such that this intensities histogram has to be designed in shape. So we have to see one image and we can understand easily. Suppose it is a new image, it is an old image. Okay, old image I am taking as an input, new image I am taking as an output. Example. So what are the old image intensity values are there? So there is something noise will be occurred. So how can we find out? With the help of histogram, I will be find out what are the noises are there. So from this input, there are some noise is there. Noise maybe. So these you have to compare these intensity values. Is there any changes? Yes, the changes are there in the histogram process. Means it is some noise are occurred. So in the new image, the noise I am removing, some noise removing. Or noise means what I am doing here? I am doing contrast. Here the black levels are high. Black color is more. So here the black color is dominating this image. So I am adjusting the contrast. Just what I done means adjusted. Just I am adjusted the contrast. So this image I am increased the contrast levels. Okay. Suppose maybe here some 100 levels are there. I am converted to the 256. So I am improved the contrast of the old image. The new image is the contrast means white. So here the white color applied. So here the output of the histogram. So this image I am apply. What is the histogram of the this image and what is the histogram of this image? So I am comparing both of this one in old image and new image. There are changes are there as in the equalization graph. There are slightly changes are there. Means here I applied some contrast levels. Here I am adjusted. Here black color is dominating. Here I am reduced the black means the white color is applied. When I am reduced the black means it is automatically it is into improving the white. So what is the importance of histogram? Histogram equalization is a computer image processing technique used to improve the contrast in an images, and it accomplishes this by effectively spreading out the most frequent intensity values, that is stretching out the intensity range of the image. So what is the importance? Why I am going for the histogram process means it is a equalization is a computer image processing. Okay, it is like a software. So easier to improve the contrast. Contrast or brightness, increasing or decreasing. So to accomplishes by effectively spreading out the most frequent intensity values, that is stretching out the intensity ranges of the image. So what are the intensity ranges are there? So what are the ranges here? 0 to 55. What is the range means? Between the 0 to 255 I have to change the intensity values. So the intensity values I changed. So histogram equalization is used in an image. As how can we are applying the histogram equalization in an image? First step, get the input image. So what is the input? So here I am taking some old image. It is the input image. And generate the histogram for the image. Find the local minima of the image. Divide the histogram based on the local minima. have the specific gray levels for each portion or each partition of the histogram. Apply the histogram equalization on an each partition. Suppose here the old image I am taking as is considering as an input image. So this input image, what is the second step? Generate the histogram for the image. Okay, I'm applying some software, histogram process software I'm applying. Okay, maybe we are using in the MATLAB. Maximum we are using the MATLAB. Okay, find the local minimum of the image. So what is the local minimum of the image? We have to find, and divide the histogram based on the local minimum. We have to divide the local minimum and specific gray levels for each partition of the histogram. So what are the specific gray levels are there in the original image? We have to find out and apply the histogram equalization on the each partition. Then we will get like this. After that, we are applying histogram process. The new image is like this. The new image equalization is like this. So the histogram can be classified into different types based on the frequency distribution of the data. So the different types of histograms are uniform histogram, symmetric histogram, bimodal histogram, probability histogram. So already we discussed what is the histogram equalization and what is the histogram. Now what are the different types of histograms here we're discussing. So it is a uniform histogram, symmetric histogram, bimodal histogram, probability histogram. We can discuss in the later. So what are the applications of the histogram processing? In digital image processing, definitely histogram processing is using for in image processing only. In image processing. So in the digital image processing, histograms are used for simple calculations in software. It is using for simple calculations in software and it is used to analyze the image. Okay, so what is the image? So I'm taking, these are the intensity values. So histogram used to simple calculations in software and it is analyzing of an image. So in this image, how we are analyzing? So what is the contrast levels? What are the intensity levels? We have to find out. So in this, we have to find out the intensity levels of the original image and the properties of image can be predicted by the detailed study of the histogram. So the brightness of the image can be adjusted by having the details of this histogram. Okay, already we know that we have to increasing our brightness adjustment. Increasing or decreasing of the brightness and contrast. Contrast level also we have to adjust. So these are the applications. Histograms are used in simple calculations in software. It is used to analyze in an image and the properties of an image can be predicted by the detailed study of the histogram and the brightness of the image can be adjusted by having the detailed of the histogram. So histogram equalization. Histogram equalization is a technique for adjusting image intensities to enhance the contrast. So I'm taking one equation. Let F be a given image represented as a MR by and MC are the matrix of the integer pixel intensities range from 0 to L minus 1. So L is the number of possible intensity values. Here I'm taking 256. So 0 to 256 minus 1. I'm taking as a 0 to 255. Why? Because I'm starting from 0, ending is 255. 0 to 255 means 256 intensities. So total 256 intensities. What is the range of means 0 to 255. So it is the equalization technique for adjusting image intensities to enhance the contrast. So what are the original intensity values are there? We have to change, we have to adjust. And here F be a given image represented as a MR and MC are the matrix of integer pixel intensities ranging from 0 to L minus 1. Here L is the number of possible intensity values of an 256. And what are the parts of histogram? Here I'm taking x-axis and y-axis. So x-axis, the intervals under which the measurement falls is shown in the x-axis. Y-axis, the values that occur within the intervals set by the x-axis is shown in the y-axis. So here two axes I'm taking, x-axis and y-axis. So x-axis, the intervals under which the measurement falls is shown in the x-axis, and y-axis, the values that occurred within the intervals, that is a y-axis. And what are the bars? So the bars are used for showing the value of the data in an image histogram, and it is a graph of pixel intensities on the x-axis versus y-axis, and the x-axis has all available gray levels and the y-axis indicates the number of pixels that have a particular gray level values. So x and y I'm taking as a bars. So what are the bars means? Bars is used for showing the values of the data, and image histogram is a graph of pixel intensities of the x-axis versus y-axis, and the x-axis has all available gray levels. Okay, so what are the intensity values are there in that image? What are the available gray levels are there? And in the y-axis, the number of pixels that have particular gray level values are there. And what are the advantages and disadvantages of the histogram? So a histogram cannot be used to represent discrete frequency distributions, and it can only be used to represent continuous frequency distributions. So what is the disadvantage is that it is compared to a box plot, is that a box plot given us a extra information such as the median, upper quartile and lower quartile of the data. So what advantages here? The histogram cannot be used to represent discrete frequency distributions. Okay, I'm not taking as a discrete, and it can be used to represent continuous. Okay, it cannot take discrete, and it will accept only continuous. And what is a disadvantage means? It is here I'm using box plot. In that box plot, extra information in the median, upper quartile and lower quartile of the data. And it is one example of histogram processing. Here before histogram or equalization. So what is the difference? Here histogram graph. So it is I'm taking as an input. So it is a after means output with graph. So here what is the input means? Here the brightness is very high. Okay, it is dominating the original image. Okay, and contrast also we have to adjust. That is the only reason here. So it is so here the contrast levels are constant. Okay, so we have to remove the contrast noises, then it will be adjusted. So after histogram equalization, so here the contrast levels are adjusted. So how I am adjusted the contrast levels? So when I am adjusting the contrast levels, here increase, here contrast is adjusting. What is the output? Okay, it is a graph of the output. So here the original image, and it is the after histogram. Okay, it is the input, it is the output with the graph, output of the graph. Okay, so what is the main reason here? Here also same thing. The contrast means black color is dominating more in the original. Okay, I have to improve means I have to reduce the black color. Then what is converted means the black colors are reduced means whitish is increased. Then it is the original after the reduction of noise or adjusting the brightness or contrast. Or contrast adjusted. Okay, contrast adjusted here. So histogram process, read the image or pixel by pixel. Read the image pixel by pixel. I'm taking 4 by 4 means total 16 pixels. Okay, we have to read each pixel by pixel and get the image size. I'm taking what is a 4 by 4, 16 pixels are, what is the size? I'm taking 1 KB example. Okay, and get the image histogram. Okay, after getting this image size, I'm going for the histogram. Why? Because is there any noises are there or any contrast levels I have to adjust? We can find out easily in with the histogram and get CDF. Okay, we have to get the original file and calculating new values by histogram or equalization. So suppose in the original image I have to improve the contrast or I have to improve the brightness. Okay, is it possible? Yes, it is possible to improve the brightness or contrast levels. Okay, so improve means I'm changing intensity values. Yes, I'm changing the intensity values of the original image. Okay, in this image 60 pixels are there. In the 16 pixels, what are the intensities are there? These intensities I have to change. So after here calculating new values by histogram equalization, here assigning the available brightness values to the new scale values. Here show graphics of the results. So graphics means we are taking as a in the form of graph. Okay, so here input, read the image of the pixel. It is a how many image? 16 pixels are there. Example I'm taking. Get image size. For the 16 image pixels, what is the size? I'm taking 1 KB example. Get image histogram. So for this 16 pixels with intensity values, what is the histogram process? What is the histogram graph? Okay, so get output of the histogram output. Next, is there any intensity values I have to change? Yes, you can change. After how can means I'm calculating new values by histogram equalization. Okay, I'm changing the gray levels and histogram values, intensity values from the original image. After the changes of the intensity values, we are assigning the available brightness values to the new scale values. Okay, I'm adjusted the brightness. You can see here I'm brightness improving or decreasing, or after then it is going to the show graph results, output result. Okay, output graph means after adjusting contrast and brightness. After adjusting contrast and brightness. So the cumulative distribution function CDF calculates the cumulative probability for a given x value. So here CDF is there now, cumulative. So this cumulative distribution function is what doing here? It is calculating the probability of a given of the x values. Here the CDF to determine the probability that random observes that as taken from the popular will be less than or equal to the certain values. Okay. Here I'm calculating the CDF values from the x values, and after the finding out the x values, we are using again the use CDF to determine the probability that a random observation that takes from the population will be less than or equal to the certain values. And histogram in digital images is defined as a discrete function. Small h of rk equal to n into k. It is one equation I'm taking. Here rk is the gray level and nk is the number of pixels. That value k is a constant and n equal to number of pixels. So what is the formula means? H of rk equal to nk. Rk is a gray level. Now what is bits? K is a constant, and what is the n? Number of pixels of the value. So in that histogram normalization, it is performed dividing each of the total pixels, P of Rk equal to Nk. Already we know that P of Rk equal to Nk by N. So P of Rk gives an estimation of the probability of occurrence of the gray level of the Rk. Rk is a gray levels, and the sum of all components of a normalized histogram is equal to 1. If I am taking sum of all the components of the normalized image, normalized means the contrast and brightness are there is no changes. Okay, that is good image. Okay, that is a sum of all components of normalized histogram and taking thus that value equal to 1. Okay, it equal to 1 when it is a normalized image. Normalized image. So it is one example. Here I am taking the this is a original image. What is a histogram graph? So you can observe here what is it means. The heavy black color is there. The black color is dominating. Okay, I have to reduce the black. Okay, reduce the black. Here what is happening? White colors are very high. Okay, we have to reduce the white. And here the noise or brightness or contrast. Here brightness. So here we have to decrease the black. Here we have to decrease the black. Here we are improving the contrast. Here we are adjusting the brightness. Okay. So after the brightness, what is the final value? Here black is reduced, white is reduced, contrast is adjusted. So what is the brightness means? It is a normal. Okay. So if it is looking good, then I will be finalized. It is the output. Okay. It is the output graph. Okay. Here these are the all our inputs. Why? Because here blackish is high, here whitish is high, here the contrast is very high. So that is the reason it is I'm going for the normalized. Means you can observe here it is going from x-axis to y-axis. Here only one side only. It is only one side. It is only one side. Okay, only one side. Means black is high. Here it is only one side or white is high. Here middle. But it is covered all. All levels are covered. Means maybe it is a final. Why? Because it is starting from here to here. It is a x-axis and it is a y-axis. Okay. It is a another one. Here the heavy black. So we have to adjust the brightness. Okay, blackish is very high. We have to decreasing the black. Okay, so here one side is there. Only the graph is it. Only one side. Means it is black is high. Here only white is high. It is one side. So here white I have to decrease. Okay, it is also adjustment of the brightness. Okay, we have to adjust the brightness. So what is the formula for adjusting it means h of rk equal to nk. So here another example. It is a low contrast histogram. It is a high contrast histogram. Okay, I am not taking normal histogram. It is a low contrast and it is a high contrast. Okay, only one middle side is there. Okay, it is covered all. So you can see here only middle side only it is covered. It here covered all sides. So it is a low contrast and it is a high contrast. Okay, it is looking good. It is a normal image. It is a blackish is high. Okay, that is means brightness we have to adjust. Here I am taking one example. The intensity values I am taking from 0 to 7. Total 8 levels. So each pixel 20 intensity values are there. So what are the pixels and what are the intensity values are there? Total the intensities are there 100. So accumulate sum of PR. Okay, I'm finding out the accumulating of the pixel means 20. Okay, so first pixel, first 0 intensity value. What is a pixel means 20. So 20 by 100 I'm taking as a 0.2. It is a PR value. Next, what is the intensity? For 1 pixel 5 intensity. 20 plus 5 because 20 plus 5 by 100. Third one, 20 plus 5 plus 25. Fourth one, 20 plus 5 plus 25 plus 10. Fifth one, 20 plus 5 plus 25 plus 10 plus 15. Okay, like that. 7 means 20 plus 5 plus 25 plus 10 plus 15 plus 5 plus 10 plus 10. So how much? 1. So what is the final value? Okay, what is the final means? I'm taking here 1.0. It is a accumulative of a sum of PR. Okay, here I'm finding out the PR value. When I'm taking means already we know that here h of rk equal to nk. So p of rk equal to nk by n. Here I'm taking PR. Here another example of the histogram equalization. Here I'm taking some intensity values from 0 to 7. That means 8. So 0 to 7. Total 8 are there. So what are the number of pixels? 25, 25, 10, 15, 5, 10, 10. Total value is 100. Count is 100. So what is the accumulation of the sum of PR? Okay, in the previous method we discussed as usual. The accumulating PR values we are finding from 0 to 7. So what is the output value? How we are finding output value means here 0.2 is there. And what are the how many total? What is the maximum value here? 7. So 0.7 into 0.2 into 7. How much? 1.4. So what is the round figure? 1. Here 0.25 into 7. What is the maximum value? 7. 0.25 into 7. 1.75. So what is the round value? 2. Here 3.5. Round value 3. 4.2. Round value 4. 5.25. Round value 5. 5.6. I'm taking 6. 6.3. 6. 7 means I'm taking 7. So the quantized output means output after changing the intensity values of the input, the final output value with intensity values are like this 1 to 7. So like this 0 to 7 these intensity values, from 1 to 7 the intensity values are like this. Okay, so it is another example for histogram equalization. So histogram matching example, histogram input image, histogram output image. So here I'm taking 0 to 7. Here the what are the intensity values? 10, 5, 25, 10, 15, 5, 10, 10. Total 100 are there. So what are the outputs are there? Is I'm changed the output values here. Here 20 is there, but I am changed it to 5. How means in the previous we discussed like this. Okay. So 5, 10, 15, 20, 20, 15, 10, 5. So the values are changed. Yes, the histogram values are changed from input to output. So when the values of the intensity values of the pixels in the input image is changed, then the histogram output is different. If I'm taking the graph, both graphs are different. Okay, it is when I'm changing the intensity values from the histogram from the original image, that is called histogram processing. Okay, it is a histogram equalization. Already we know that 0 to 7 I'm taking. So what are the pixel values are there? 10 to 10, 10, 5, 25 like this. I'm taking PR value. I'm taking what are the sum value? Already we discussed here. 1 to 7. 1, 2, 3, 4, 5, 6, 6, 7. Okay. These are the 7 values are there. So it is the input side and it is the output side. Okay. So another another example I'm taking as a map R to S and S to V, V to Z. So here R to S and S to V and V to Z. So R to S 0 to 7. So what are the output values? 1 to 7 like this. Here V to 0, 0 to 0, 1, 2, 3, 4, 5, 6, 7, 7. Here Z values 0 to 1, 2, 3, 5, 6, 7. So is the values are changed or not? Yes. Here the values are different. Here the values are different. Here the values are different and here the values are different. Okay, I'm taking as a mapping of the images of the pixels. Here actual output histogram. These are the input levels are there and it is the output levels are there. So here 0 to 7 and 1, 2, 2, 3, 4, 5, 5, 6. Here 1, 2, 3, 4, 5, 6, 6, 7. Is the values are changed? Yes, the values are changed here. The histogram values are changed. The intensity values are changed. Then it is a histogram process. Why? Because are the improving the brightness? Yes, I was improved the brightness of the original image. So here also 0 to 7. So what are the pixel values are there? So from the input to output is the brightness, contrast, intensity values are changed. Yes, I was changed the intensity values from input. Then it is calling as a histogram process with the help of histogram matching. Okay. these are the some basic gray level transformations. So what is the image enhancement? Image enhancement is provide to better contrast of more detailed image compared to non-enhanced image. And image enhancement has very applications used to enhance medical images, images captured in remote sensing, images from satellite. So what is the equation for the image enhancement? S equal to capital T of R. So output equal to transformation function with input. Output equal to transformation function with input. That is the image enhancement. So what is the exact meaning of image enhancement means? Image enhancement is provides a better contrast of an image, more detail of compared to non-enhanced image. Image enhancement has very applications, is used to enhance medical images, medical capturing in remote sensing, images from satellite, etc. So already in the previous we discussed image enhancement. Yes, in the image enhancement, histogram processing is also one image enhancement technique. So image enhancement technique is for histogram processing. To what is the use means to improving the contrast and effectively spreading out the most frequent intensity values. Okay, and image processing, histogram of an image normally refers to the histogram of the pixel intensity values, and it is a graph showing the number of pixels and each different intensity values found in that image. So image in the image, original image, if you are changing the intensity values, so that when I'm changing the intensity values on the original image, that is process is called image enhancement. Okay, this done by histogram equalization, and it is a histogram equalization is a technique for adjusting of the image intensities to enhance the contrast, and it is usually increasing the global contrast of many images, and it is using for providing the sophisticated method for modifying the dynamic range and adjusting the contrast of an image. So it is one sample example, old image and a new image. I am adjusted the brightness and contrast of the original image. Okay, so the equalization, the graph is like this. Okay, comparing with the graphs, is there any changes in that? As the modifications are there means the brightness and contrast levels are changed, the intensity levels are changed. How can I know means I am observing the graph. So what is the importance of the histogram? Histogram is a computer image processing technique used to improve the contrast of an image, and it is effectively spreading out the most frequent intensity values and stretching out the intensities range of the image. Okay, what are the steps means? I'm taking first we have to select the input image, input selection. So after then generate the histogram of the image. Okay, we have to take in the graphical graph. Then find out the local minimum of the image. So local minimum means we are finding out the adjust brightness and contrast levels and divide the histogram based on the local minima and specific gray levels of each partition of the histogram and apply the histogram equalization on each partition. So what are the different types of histograms means? Uniform histogram, symmetric histogram, biomodel histogram, and a probability histogram. So what are the applications means? Histograms are used for simple calculations in software, and it is analyzing the image, and we are predicted by the detailed study of the histogram, and the brightness of the image can be adjusted by having the detail of the histogram. So what is the definition of histogram equalization? It is a technique for adjusting image intensities to enhance the contrast. It is the technique for adjusting image intensities to enhance the contrast levels. So here what is the equation means? Here I am taking F be given of representing as a MR and MC is a matrix, and what are the ranges means 0 to L minus 1. Here L is the number of possible intensity values. Here I am taking 0 to 255. What is the equation means? 0 to L minus 1. L means what are the intensities means 256 levels are there. So 256 minus 1, it is a 255. So 0 to 255 are the intensity levels. So how we are taking as a histogram means I am taking as a x-axis and a y-axis. And what are the advantages means we are representing in the we are not representing in the discrete form, we are representing in the continuous frequency distribution. And what is the disadvantage means compared to a box plot, that it is given the extra information such that median, upper quartile and lower quartile of the data. And it is one sample example of the input image before histogram and it is a after histogram. So what is the difference means here the contrast is high, so we have to changing the contrast levels. So we are changed. It is the original image, output image. Okay, it is the graph of the output. It is the input graph. Okay, here also image after histogram. It is a before means it is the original image. So here what it means contrast adjustment. We have to increasing the contrast. Okay. Here, after the adjustment of contrasting the original image, here it is a histogram equalization of the input, histogram equalization of the output. So it is one block diagram. Here, first input is the image. Read the image of the pixel by pixel. Okay. So the image with pixel by pixel means 16 example taking 16 pixels. Or 256 pixels, whatever may be. So get image size from the pixels. What is the size we have to find out, and get image histogram and get the CDF means cumulative distribution function. We have to find out the value of the CDF. Okay. After finding out the CDF, how can we are calculating the new intensities means by histogram equalization. We have to find out the new intensity values. We have to calculate. So new means in the original image we are changing some intensity values. Okay, after the changing of the intensity values we have to find out the calculation of the histogram equalization and assign the available brightness values to the new scale values, then show the graph results. So the cumulative distribution function calculates the cumulative probability for a given x value. So the cumulative distribution function is determining the probability of the random observation that taken from the population will be less or equal to the certain value. It is a formula for finding out the discrete function of the histogram digital image. H of Rk equal to Nk. Here Rk is the gray level and K is the number of pixels and K is a constant and N is the number of pixels of the image. So histogram normalization P of Rk equal to Nk by N. So these are the sample, some examples are there. Here input image, the black color is high. Here the whitish is very high. Here the contrast is not adjusted. So in the final output, I adjusted the black colors, white and contrast. It is a normal. It is a output image with a normal. Okay. Here the graphical histogram process graph of the each image. It is a final output image. Okay. It is another example. Here the H of Rk equal to Nk. I applied the formula for histogram processing. So here the black is very high. Here white colors are very dominating. So you can observe this one. Only one side means black color is dominating. Only in the graphical here white colors are dominating. Okay. So we have to convert it to the normal. So it is the intensity values with pixels. I am finding out the accumulating value, sum of PR. Here I am finding out the histogram equalization of the accumulating and output values and output image with pixels. So what are the pixels? What are the intensity values of the input? After the changing of the intensity values, what are the output intensity values? So what is the formula I have applied means sum of PR. Okay, I am applying the PR value. Here accumulating sum of PR, the final output values. Here first one is a histogram input images and this is a histogram output images. Here I am taking 0 to 7, 0 to 7. The pixel values are changed from input to output. And it is a histogram equalization. Here the matching of the example of mapping. Here I am taking R to S and here V to Z. Here actual output histogram. It is the input. It is the actual output of the histogram. These are the image enhancement definition. So these are the histogram processing techniques. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.